All right, stretch is our last kind of transformation. The big thing, if it's on the inside, it affects all of the values. All right, example, if g of x is 2 times f of x, everything in f of x gets multiplied by 2. In this one, only the x values are essentially doubled, so that y-intercept is not going to change. That's really the only difference. This affects everything. This just affects the y-intercept. Let's get a look at how this is going to visually look. So 2x plus 1 is where I'm going to start from. I got a positive 1 slope. I've got a positive 2 slope, rather, up 2 over 1. I've got a y-intercept of positive 1. This is going to look just like this. I'm going to put them both on there so we can get that done. This is what it looks like. Now, if I double every value for y, it's going to look like this. At 0, I'm going to go 2, because for 0 for x, we had a 1 for y, so now we'll have a 2 for y. At 1, we had a 3 for y, so now we'll have a 6 for y. And you'll notice instead of going up 2 for every 1 we go over, we're now going up 4 in our new line. Instead of 5 for y, when I've got x equal 2, I'll have 10 for y when x equal 2. So this line, every point gets doubled, and that includes your y-intercept. This other one is going to be a little different because you're not doubling necessarily the y value. Your graph is going to act like it has a doubled x value. As an example, if you double 0, you still have 0. So it's going to act like x is 0. When you double 1, you get a 2. So it's going to act like x is 2. You'll be up here in the 5. When you double 3, it's going to act like it was 6. So you'll get a 13. It'll be up. But anyway, double 2, it'll be a 4. What was 4? 4 was 9. It's going to be just like this. But anyway, it acts like a double of the x that you had at first. All right? So instead of the function value for 1, we're going to use the function value for 2. Instead of the function value for 2, you would use the function value for 4. And in essence, what that does is double your slope. Doubles your slope. So instead of up 2 over 1, it's going to be up 4 over 1. And it's going to start from the y-intercept, the original y-intercept. Let's get it on to the next page. We have f of x is going to be shifted 5 units to the right. Remember, if I want to shift it to the right, it's going to be inside. So I'll have, we'll say g of x is f, and I want to move it to the right, so I'm going to take it inside the parentheses. I want to move it 5 units, so I'm going to go minus 5. Shift it up 7 units. My new equation is going to be the same as my old, but I want to shift the whole thing up 7 units. So I take all those y values and I push them up 7 units. This one reflected across the x-axis. Now this is just a negative sign. Let me check, double check. It's going to be on the outside over here. When we want to flip it across the x, all the y's are going to reverse. So I take the entirety of the function and I multiply by negative 1. My last one, if I want to make the slope 3 times as steep and I don't want to change the y-intercept, I'm going to take and drop that 3 on the inside. So this will make that slope 3 times as big, but it won't change the y-intercept. Y equals is much easier. They are used more for application. This one is so much better. We'll talk about that on Monday. For y equals, let's say you start off with 2x plus 1. Shifting it up or down is very easy. You just change the y-intercept. Making the slope twice as big, you just double the slope. And then if you want to shift it left or right, you're still going to use that up or down to do so. It's not, I mean, it's super awesome. Love this one. We'll talk about that on Monday. For right now, function notation. If you have any other questions, take a look at your book. They've got some solid examples. We'll see you on Monday.